Today we're going to be looking at a geometry problem, and we're going to start off quite simple, but then keep making it harder and harder, and see if you can solve all of them and make it all the way to the end. So let's jump right into the first problem. We've got a square drawn inside a circle with radius 1. What's the area of the square? Pause the video now if you want to try it, and I'll reveal the solution in a few seconds. Well, we can start by drawing in this diagonal and then considering the triangle highlighted here, which is a right angled triangle, so we'll be able to use Pythagoras on it. And let's call the length of the square's sides S, which we can label here. And because this long diagonal is a diameter of the circle, we know it must have length too. So then Pythagoras gives us that s squared plus s squared equals 2 squared, or 2s squared equals 4. So s squared is 2, and that's the area of our square. Now, to make it a little bit more tricky, our square is inside a semicircle, still with radius 1. So what's the area of the square now? Again, pause the video if you like before I show you the answer. So this time, the key line to draw is from the centre of the semicircle out to the corner of the square. And this gives us another right angled triangle, just like last time. But now one side is a side of the square, so that has length s, but the edge on the bottom is only half the length, so s over 2. And the hypotenuse is a radius of the circle, so that is 1. And again, using Pythagoras, we get that s squared plus s squared over 4 equals 1. Then multiplying by 4, we have 5s squared equals 4, so our square has area 4 over 5. And if you got that, good job. Now for the final problem, and this one's quite a bit tougher than the last one. So now our square is inside a quarter circle, still with radius 1. What's the area of it this time? Go ahead and pause the video and I'll explain the solution in a moment. Well, there's already one right angled triangle there for us to use, and we'll stick with S to refer to the side length of the square. But we don't know what the other sides of this triangle are yet, only that the triangle is isosceles, so they're the same length, which we can label as x for now. Then Pythagoras tells us that 2x squared equals s squared. But we're going to need another equation to eliminate x, and we still haven't used the fact that the radius is 1. So how could we do that? Well, let's add in the radius to the far corner of the square. And if we draw the diagonal line across the square, that gives us yet another right angled triangle. And this time the short side is x, the hypotenuse is 1 because it's a radius of the circle, and the last side is root 2s because it's a diagonal of the square. So this gives us another equation involving s and x, and we can then substitute from one equation into the other so that we get something only involving s. And solving that, we get that the area is 2 over 5. If you managed that one, really well done. It's not easy. So how did you get on? Did you find them tough or breeze through them all? Let me know down in the comments, as well as anything you'd like to see in future videos. Thanks for watching, and I'll see you next time.